Hey guys, what's up? We're here for another video, this time on the trigonometry point 2 notes and dimensional analysis. We're going to start with some warm-up problems, so try these on your own, and then you can come back and we can focus on some of the other problems. So let's try to first find the angle in degree that subtends a circle with a radius of 3.5 feet and creates an arc length of 5 feet. We remember the formula, because again we're trying to find the angle, and we know the arc length. So remember, S is equal to the arc length. S is the arc length is equal to the radius times theta. Theta is always in radians, so just be aware of that. We want to do S is 5. We know the arc length is 5 equals the radius, which is 3.5. Times theta. Theta is not given to us, but we can find it pretty easily. We just do 5 divided by 3.5, and then you're going to get theta equals roughly 1.43 radians. However, did not ask us for the final answer in radians. We want to convert that into degrees. So in order to convert that into degrees, we want to use the old formula that we learned last video. And that video, we said that to convert radians into degrees, we do 180 over pi times the number of radians. So we do 180 over pi times the number of radians, which we know is 1.43. So we're going to multiply these together. Grab out my phone to do this quick calculation real quick, and you guys can do the same. So we can just do 180 times 1.43, and then divide that number by pi. And this will give us roughly 81.93 degrees. Again, this time we don't know the theta, so we have to find it. So we have 5 is the full arc length equals 3.5, which is the radius times theta, the degree, or the measurement, which is in radians. So we take the 1.43 that we find and multiply it by 180 over pi. That will give us our degree in actual degrees. All right, next thing we want to do is find the radius. So again, we're looking for the radius, the r, of a circle that's been subtended by an angle of 2 pi over 3 radians. We have radians, it's really good, to create a sector of a 40 meters squared. Okay, so we don't have to convert back to degrees at any point here. So we have 40 as our area, because we have area equals 1/2 times r squared theta. We know 1/2 never changes, it's always just 1/2. R squared, we don't know yet. We don't have a radius, and our theta right here is 2 pi over 3. Cool. So you have 1/2 times r squared times 2 pi over 3. Now I can just do 1/2 times 2 pi over 3. This gives us 40 equals 1/2 times 2 pi over 3 is just pi over 3 times r squared. Now I can do 40 times pi, and we should get, 40 times 3 divided by pi. So we have 40 times 3 is 120, and then divided by pi is roughly 38.197 equals r squared. So now we're just going to take the square root of that number, which is 38.197, and that ends up giving us r equals 6.18. Again, you can just do this in your calculator. And remember, we want to do this with meters because that's what it is given to us here. Radius equals 6.18 meters. Again, this is just review. And now we're going to get into some of the new stuff we're going to learn today, which is dimensional analysis for linear and angular speeds. Some notes is that we want to have linear distance is found by determining the circumference and equating it to 1 revolution, and then cancel units. What we do know is that 2 pi r is equal to the circumference of a circle. That is a note you might want to take. 2r is equal to the circumference of the circle. These are all word problems, so I know it's kind of going to be rough. A lot of you don't like them, but I think they're kind of cool. Let's just use like some real world ideas into our math. All right, let's assume there's a hard drive. Hard drives are circular. I know many people don't know what they look like. Let's just imagine they're like a disk. So they're a circular disk. And a computer, and it's circular, it rotates at 7,200 revolutions per minute. The idea behind that is that it spins 7,200 times every single minute. Like it's real fast. What is the angular velocity in radians per minute? So we have to figure out what we have and what we want to get to. So we know we have revolutions per minute. That is something that we are given. So we'll say rev per minute. Our goal is to get to radians per minute. That is our goal. So the way you can do that is by canceling out the units that we don't want. So we start with 7,200 revolutions per 1 minute. Okay, that's great. We want to multiply that by the amount of radians it takes to do 1 revolution. And we know 1 revolution of a circle is how many radians? That's 2 pi. So this is for all circles. So if you do 1 trip around a whole circle, 1 revolution is equal to 2 pi radians, 2 pi. So we would have times 2 pi radians for every 1 revolution that you do. What's kind of nice here is that this is really just a one-step problem, because when you multiply these things, you want to cancel out your units. So I have revolutions on the top, revolutions on the bottom. Cancel here, cancel here. Now the only ones I have are radians and minutes, which is exactly what I want. I want radians per minute. So 7,200 times 2 pi ends up being 14,400 pi radians per minute. And if you wanted to multiply the pi and the 14,000 together, you would get 14, or not 14, my bad, 45,238 radians per minute. This is the same thing. These are the same. One just is an exact answer, and the other one is a rounded answer. So again, your big goal is to figure out what you're trying to get to and cross out the units when you can. Remember, the two big things is 2 pi r is the circumference of a circle, and 2 pi radians is equal to 1 revolution. All right. The radians of each wheel of a car is 15 inches. Okay, that's cool. So we know that the radius, the r, is equal to 15 inches. If the wheels are turning at a rate of 3 revolutions per second, so we know there's a 3 revolutions per second, we want to figure out how fast the car is moving, and we want to express that in inches per second and then in miles per hour. So we want to start with revolutions per second, because that's what we're given. And the first thing you want to get to is inches per second. So you have inches per second. All right. We start with revolutions per second. That's the 3 that we have, the 3 revolutions per 1 second. And our goal is to first get that revolution into inches. So the way you can do that is multiply. We know that the whole way around, the whole revolution is equal to 2 pi r for the circumference. So we know 2 pi r, in this case, is the same thing as 2 pi times the radius, which is 15, which is also equal to 30 pi. So we know that 30 pi inches per one revolution. Because we know one full trip around is 30 pi, because we know the circumference is 2 pi r. At this point, this would get rid of our revolutions and our inches, or sorry, just our revolutions, because that's all we need to get rid of. So we want to get rid of revolutions here and revolutions here, and we're left with 90 pi inches per second. Or if you wanted to get a decimal answer, you could do 282.74 inches per second. And that's all well and good, but it also asks us for miles per hour as well. So when you want to do that, you have to do 90 pi inches per 1 second. And I want to convert that into miles per hour. So I had inches per second, now I want to go to miles per hour. So I have to convert inches to miles and seconds into hours. I'm going to do seconds to hours first. So what I want to do is say how many hours it's going to take, how many seconds will take for an hour, and that is 3,600 because 60 times 60. 60 seconds in 1 minute and 60 seconds in 60 minutes in 1 hour. So 60 times 60 is 360 seconds per 1 hour. And that's going to get rid of our seconds for us, which we want to get rid of because we're trying to get to hours. So we've converted seconds to hours now. And now our goal is to convert from inches to miles. And the way you can do that is we know there's 12 inches in a foot and 5,280 feet in a mile. So what you can say is 1 mile for every 63,360 inches. And what's nice here is that these inches cross out here and cross out here. So you're left with just miles and hours, which is what we wanted. So we have 90 pi times 3,600 times 1 on the top. We have 1 times 63,360 on the bottom, which ends up being, when you do all the math in your calculator, roughly 16.06 miles per hour. Again, your goal is to get rid of all of the units. Our next question says, a spinner balancer rotates a wheel of a car at 480 revolutions per minute. That's really good to know. If the diameter of the wheel is 26 inches, what is the road speed that's being tested? And express our answer in miles per hour. So we start out with revolutions per minute. So we have revs per minute. And our goal is to get to, miles per hour. Miles per hour. So we're converting minutes to hours and revolutions to miles. So the way you can first do that is we have inches, so we have to convert that to our miles too, which is going to be, a little bit of work. So this one, we start with 480 revolutions per minute, and we want to convert this. We know that in order to get inches per revolution, we want to work with this right here. Remember, 2 pi r is the circumference of a circle, and our radius is 13, because our diameter is 26. So we have 2 times pi times 13, which is 26 pi. So we know we have 26 pi inches over 1 revolution it takes 26 pi inches to go 1 revolution around the spinner balancer. Next, we're going to do miles and inches to get rid of that. So we're going to convert inches into miles. And the way you can do that is just do, let's see here, 1 mile, and that is equal to, what, 63,360 inches. What's nice now is we can see a few things cancel out. We can see inches cancel out here and here, and we can see revolutions cancel out here and here. So now we have miles, which is really good. Now all we have to do is get to hours, which is a pretty easy conversion because we know there's 60 minutes in an hour. So all we have to do is say 60 minutes per 1 hour, and we can still cross out this minutes here and this minutes here. So now we're left with just miles and hours, and we can just multiply straight across, and this ends up being 37.13 miles per hour. When you multiply straight across, you do 480 times 26 pi times 1 times 60. And that's on the top, and on the bottom it's 1 times 63,360 times 1. And just divide those two numbers and you get 37.13 miles per hour. And the last part of this question asks us, how many revolutions per minute should the balance be set to test a road speed of 80 miles per hour? And the way you can do that is we know we have 80 miles per hour, and we want to convert that into our inches first. So we do 63,360 inches for every 1 mile that goes. Then that's going to nicely cancel out our miles for us. Now I want to convert my inches into revolutions. So I can do 1 revolution for every 26 pi inches. This is going to cancel out the inches. And then last but not least, we also have to convert our hours back into minutes. And then we can do 1 hour is equal to 60 minutes. That's going to cancel out our hour here and our hour here, leaving us with just revolutions and minutes. 80 times 63,360 times 1 over 1 times 2, 26 pi times 60. And that's going to give you 1,034 revolutions per minute. All right, 2 more to go. We have a cable car museum. You can see 4 cable cars. Lines are used to pull cable cars and down the hills of San Francisco. Each cable car travels at 9.55 miles per hour, so that's going to be our starter, caused by a rotating wheel whose diameter is 8.5 feet. How fast is the rotating wheel? And express your answer in revolutions per minute. So again, we want to start with our miles per hour, and then we want to convert that into revolutions per minute. So we start with 9.55 miles per hour, 1 hour. And then we want to get rid of the hours and convert them to minutes. So we know we have 60 minutes for every 1 hour, but I put them in the wrong position. My bad. So we have 1 hour up here is 60 minutes because I want to get rid of the hours. So I have the hour on top, and that converts or crosses out the hour on the bottom, which is what we wanted. So we've already converted to minutes now. We want to just convert to revolutions. So we know 8.5 feet. So we first have to convert our miles into feet, which ends up being, let's see here, 1 second. We have miles into feet is 5,280 feet for every 1 mile traveled. that's going to get rid of our miles. So we have feet. But now we're going to use our feet, and the reason we had to get to feet is because our diameter is given to us in feet. And we know that 2 pi r is equal to 1 revolution, or 1 revolution is equal to 8.5 pi feet. That's going to cancel our feet here and our feet here. Remember, this is found by doing 2 pi r. Diameter is just 2r, so we have 8.5 pi. Next, we multiply straight across, 9.55 times 5,280 times 1 times 1, and then that's over 1 times 60 times 1 times 8.5 pi, which ends up giving you 37.41 revolutions per minute, because that's what's left over. And the last one says a riding lawnmower has wheels that are 15 inches in diameter, and they're turning at 2.5 revolutions per second. So I know I have revolutions per second right now, and I know that I am trying to get to radians per second. So we just have to convert revolutions to radians then. We know 15 inches is the diameter. All right, so if we have those things, we start out with 2.5 revolutions per second, 2.5 revolutions every 1 second. So the first thing I gotta do is get that revolution, and the way you can get the revolution is just do, we know 2 pi radians is equal to 1 revolution. That's going to get us radians per second. So that crosses out the revolutions here and the revolutions here. That gives us about 15.7 radians per second. Again, this is just calculator work. The next thing, the last thing, how fast is the lawnmower traveling in miles per hour? So you're given this 25 revolution, or not 25, 2.5 revolutions per minute. And our goal is to get to miles per hour. So first I'm going to convert my minutes into hours by doing 60 minutes for every 1 hour. And I want to convert my revolutions to miles, but before you do that, you need to do the conversion into inches, because that's what you're given. We know 15 pi is the number of inches it takes for 1 revolution. And the last, we want to convert inches into miles, and the way you can do that is there are 63,360 inches for every 1 mile. And when you cross out all of your things to make sure you're good, so revolutions is gone, minutes is gone, inches are gone, multiply straight across from the top, multiply straight across from the bottom, and you're going to be given 0.112 miles per hour. And that's it. Go ahead and go over this on your own, go over the video again if you need to, make sure you know how to do these problems, and I will talk to you next time. Have a good day.